Good morning students. Today we are going to discuss about symbol table. Now what is a symbol table? See what are the various symbol table entries and what are the various operations performed on symbol table and how we are going to implement the single symbol table. See all those things we are going to discuss today here. In previous class we have studied about what is a runtime environment, so what is a heap management, what are the various techniques in heap management, all those things we have studied. Now in this class we are going to concentrate on only symbol table. See before going to see what actually a symbol table, first of all we will see a brief discussion about compiler. See what actually the compiler, so this is the syntax of a compiler. See, compiler will take the source program and as input and it will give the target program as output. Up to this point, we have treated a compiler as a single box only that maps the source program into a semantically equivalent target program. But inside this box, if we open this box, we will see that there are two parts. That is, first one is analysis part and the second one is synthesis part. As we know, analysis part is nothing but we can say a front end. See, synthesis part means it is a back end. That means if you take the various phases, see, analysis part means syntax, lexical analysis, syntax analysis, semantic analysis, at the same time intermediate code generation, whereas synthesis part means code optimization, at the same time code generation. See here actually what the analysis part will do. See, analysis part will break up the source program into constituent pieces and imposes as a grammatical structure on them. It then uses the structure to create an intermediate representation of the source program. So at the same time, if the analysis part detects that the source program is either syntactically ill-formed or semantically unsound, then it must provide informative messages so the user can take a corrective action. So at the same time, this analysis part also collects information about the source program and stores it in a data structure called as symbol table. See here, at the same time it passes along with the intermediate representation to the synthesis pod. See, what is a synthesis pod? If you take the synthesis pod, here the synthesis pod construct a desired target program along with the target program from the intermediate representation and the information in the symbol table. See, as you know, analysis pod, or we can call it as a front end, and the synthesis pod we can call it as a back end. See, front end pod means analysis pod, back end pod means synthesis pod. See, let us see what is actually a symbol table. What actually a symbol table? A symbol table are data structures that are used by the compiler to hold the information about the source program. Next, what is the symbol? Symbol table is one more definition of symbol table. Symbol table is a data structure created and maintained by compiler to store information about the occurrences of various entities such as variable names, function names, or objects, or classes, or interfaces, etc. See, symbol tables is used by both the synthesis and analysis part. That means both the synthesis part and analysis part, these two parts can be used by the symbol table. That means the symbol table will uses the both part, that is analysis part at the same time synthesis part. When identifier are found, they will be entered into a symbol table which will hold all relevant information about identifiers and other symbols, variables, constant, procedural statements, etc. See, what the symbol table is used by various phases of compiler. Generally, we know that we have a total of 6 phases are there. How the symbol table is used by the various phases of compiler. That means how the symbol table will use this lexical analysis, how the symbol table will use the syntax analysis and a semantic analysis, intermediate code generation and a code optimization and at the same time code generation. See, what is the first one is how the symbol table is used as the lexical analysis. See here, lexical analysis creates a new table entries in the table. Example is like entries about a token. Like next one is how the symbol table uses the syntax analysis. It is nothing but in syntax analysis adds information regarding attribute type, scope, dimension, a list of references, etc. Like no, whereas if you take the semantic analysis uses available information in the table to check for the semantics, that is to verify that expression and assignments are semantically correct and update it accordingly. If it is correct or not, each and every time we are going to check it out. Then next one is, fourth one is intermediate code generation. See, intermediate code generation refers symbol table for knowing how much and what type of runtimes is allocated, and the table helps in adding temporary variable information. Like no, what about the code optimization? How the symbol table will use the code optimization? See, code optimization uses information present in symbol table for machine dependent optimization. And finally, code generation. See, code generation means here the generate code by using address information of identifier present in the table. Next, symbol table may serve the various purposes depending upon the language in hand. That is, first one is to store the names of all entities in a structured form at one place, and to verify if the variable has been declared. Next, to implement the type checking by verifying assignments and expressions in the source code and semantically correct, to determine the scope of a name. So these are the 4 points. Next, a symbol table is a simply a table which can be either linear or hash table. It maintains an entry for each name in the following format. So that is symbol name, at the same time type and attribute. That is, this is the syntax of symbol table. See, first one is symbol name, type and attribute. This is the syntax of symbol table. See, for example, if a symbol table has to store the information about the following variable declaration, that is static int interest. So this is the declaration we are going to take. If you want to represent this in the form of symbol table representation, then it should be store the entries such as, see, first one is interest and the next one is static. In this way we are going to store the statement of this one by using the symbol table structure. Next, the attribute clause contains the entries related to the name. Here, the attribute clause contains the entries related to the names. Next we are going to talk about the symbol table entries. So, what is meant by symbol table entries? Each entry in a symbol table is associated with attribute that support compiler in different phases. See, what are the various items stored in symbol table? There are some items, those items we are going to store into the, generally those items we are going to store into the symbol table. What are the various items? See, first one is variable name and constants. See, at the same time, procedure and function names. Procedures and function names also we are going to store into the symbol table. At the same time, literals, constants and strings. And at the same time, compiler generated temporaries or temporary variables generated by the compiler. At the same time, labels in source language or source program. So all those things we are going to store into the symbol table. These are the items stored into the symbol table. Next one, we are going to talk about the information used by the compiler from symbol table. See, what are the information we are using by the compiler from the symbol table? So information is, first one is data types and names. Next one is declaring procedures. Next one is if the structure odd or record, then pointer to the structure table, then number and type of arguments passed to the function. So these are the information used by the compiler from the symbol table. Next you will see what are the various operations on a symbol table. If you see the operations on symbol table, we have so many operations are there. Here we have one tabular column. So these are the various operations along with functions. See, first one is insert is one operation, lookup is one operation, allocate, free, set attribute, get attribute. All these are the operations of a symbol table. If you take any symbol table, the majorly we are going to consider these are the various operations. See, first one is insert. See, what is a insert? Insert is nothing but insert a name in a symbol table and return a pointer to its entry. We can call it as a insert. Next, second one is lookup. See, what is meant by lookup? To search for a name and a return pointer to its entry. It is nothing but lookup. See, next one is allocate. See, what is meant by allocate? Allocate means to allocate new empty symbol table. See, if you want to allocate new empty for a symbol table, then we call a function called as operator called as operation called as allocate. Next one is free. What is a free? Free is nothing but to remove all entries and free storage of symbol table. See, if we want to store some information in the symbol table, definitely first we have to create space. That symbol table is free or not. So in order to free this space, in order to vacate this space, we are going to use the operation called as free. Next one is set attribute. See, what is meant by set attribute? It is associate an attribute with a given entry, whereas next one is get attribute. See, why we are using this get attribute? Get attribute means to get an attribute with a given entry. So these are all the operations performed by the symbol table. See, what actually insert? See, this operation is more frequently used by analysis phase. That is, the first half of the compiler where tokens are identified and the names are stored in the table. This operation is used to add information in the symbol table about unique names occurring in the source code. The format or structure in which the names are stored depends upon the compiler in hand. At the same time, an attribute for a symbol in the source code is the information associated with that symbol. At the same time, this information contains the value, state, at the same time scope and the type about the symbol. The insert function takes the symbol and its attributes as argument and stores the information in the symbol table. See, for example, here int a. For example, int a. If we write int a, it should be processed by the compiler as insert a comma int. See, if you take this instruction, it can be written by, it can be taken by the compiler as insert a comma int. Next, we are going to talk about the operation called as lookup. See, it is used to search a name in the symbol table to determine if the symbol table exists in the table, or if it is declared before it is being used. At the same time, if the name is used in the scope, if the symbol is initialized or not, if the symbol declared multiple names. In order to determine all these things, we are going to use the operation called as lookup. The format of lookup function varies according to the programming language. That means, based on the programming language, the format may changes depending on the languages. The basic format should match the following. That is, we can write lookup symbol. We can write lookup symbol. Here, this method return, so this is the method. This method returns 0 if the symbol table does not exist in this, if the symbol that does not exist in the symbol table. If the symbol exists in the symbol table, it returns its attributes. stored in the table. So this is the syntax of the lookup symbol table. Next, what are the various implementations of symbol table? How we are going to implement the symbol table? See, the following are the some commonly used data structures for implementing the symbol table. In order to implement the symbol table, we are going to use some data structures called as list, linked list, and a hash table, and at the same time BST, that is nothing but binary search tree. Binary search tree. See, what is meant by list here? Next, what is meant by linked list? What is meant by hash table? What is meant by binary search tree? All these four things we are going to discuss in the implementation of symbol table. See, first one is list. So in this method, an array is used to store names and associated information. A pointer called available. A pointer called available is maintained at the end of all stored records, and new names are added in the order as they arrive. To search for a name, we start from the beginning of list till available pointer, and if not found, we get an error, use of undeclared name. At the same time, while inserting a new name, we must ensure that it is not already present, otherwise error occur. Why? Because multiple defined name. Insertion is fast, that is order of 1. But lookup is slow for large table, that is order of n, that is insertion is large. Next, advantage, the major advantage is that it take minimum amount of space. See, the major advantage is it take minimum amount of space. Next, second implementation is linked list. See, what is actually linked list? Linked list means it is a collection of nodes which are connected by a link. We can call it as a linked list. Of course, this is a node, this is a node, this is a node, this is a node. See, each node contains two parts. One is address part, one is for data part. This is data part, this is for address part. See, by using this linked list implementation also, we are going to implement the symbol table. See, here a link field is added to each record. Searching of name is done in order pointing by a link of link field. A pointer, we are going to maintain a pointer called first. A pointer called first is maintained to point to first record of the symbol table. See, if we mention the first means it is the first record of a symbol table. It is the first record of a symbol table. If you mention the first means it will be the first record of a symbol table. See here in this one, insertion is fast, that is order of 1 only. But lookup is slow for large tables, that is order of n only. Whereas next implementation is hash table. Next one is hash table. See, what is meant by hash table? See, hash table is nothing but in this hashing scheme, we are going to use two tables are maintained, that is hash table and the symbol table, and is the mostly commonly used method is implement the symbol table. A hash table is an array with index range from 0 to table size -1. 0 to table size -1. These entries are pointer pointing to name of a symbol table. To search for a name, we use hash function that will result in any integer between 0 to table size -1. At the same time, here in this one, insertion and lookup can be very fast, that is order of 1, that is order of 1. At the same time, advantage is very quick, that means searching is quick search is possible. Disadvantage is that hashing is complicated to implement. And the last one is hash. After completion of this hash function, we are going to study about the BST, that is binary search tree. So what is meant by binary search tree? See, this is the another approach to implement symbol table is to use of binary search tree. That means in this one we use two link fields, that is one for left and one for right. One for left and one for right. So this is the binary search tree. This is for left field, this is for right field. This is the parent, this is the children, this is the children. So at the same time, all names are created as a child of root node that always follows the property of binary search tree. That means here the children which are created for this parent that should follow the properties of a binary search tree. See, what are the properties of a binary search tree means? See, always binary search tree is a binary tree. It means it have one root and two children. It have one root and a max. What is a binary tree? Binary tree is a tree in which it have maximum of two children. Maximum of two children means either 0 or 1 or 2. It should not be greater than more than 2. That means it is a binary search tree. So it is not a binary search tree. Why? Because we have 3 children. Whenever we are using the binary search tree for implementation of symbol table, definitely we are going to follow the properties of a binary search tree. Here in this one, insertion and lookup are order of n log n. Order of log n base 2 and an average. So these 4 are the implementations of symbol table. Okay, so this is regarding symbol table. What is a symbol table? What are the symbol table entries and what are the various operations and how we are going to implement the symbol table. Okay, thank you very much. Please subscribe DBS Talks.